Hello, hello, and welcome to the Bitcoin++ Oxford debate. I'm your moderator, David Zell. I'm the president and co-founder of the Bitcoin Policy Institute. We're a DC-based think tank focused mostly on mempool and relay policy. The purpose of debate in the Platonic form is to get incrementally closer to truth. So my hope is that today's debate is, above all else, educational. The topic the debaters will be addressing today is the following. Quantum FUD, defined as fear, uncertainty, and doubt, is a greater threat to Bitcoin than quantum computing. This is a little different than most debates. This is not a democracy. The winner of today's debate will not be the debater who receives the most votes, but instead the debater who changes the most minds. So the win is sort of a function of the delta in minds changed rather than winning a majority of the ballots. And you all play an extremely important role in that, to that end. So please go ahead and scan this QR code. We want everyone to vote before the debate begins. So do this with haste. Yes, you do have to sign in with GitHub. To the QR code there. So we'll give everyone 2 or 3 minutes to cast their votes. Remember, the topic is resolved. Quantum FUD is a greater threat to Bitcoin than quantum computers. Yeah, I didn't set this up, so again, I'm just focused on educating policymakers about BIP 110 and spam and CP and all that stuff. So, Huh? Oh yeah. Well, everyone's done that. Introducing our debaters. On the affirmative, we have Rearden, Bitcoin researcher and consultant. And for the opposition, we have Alex Pruden, the founder and chief executive officer of Project 11, a venture-backed startup focused on quantum computing. Brief rundown of the structure. Each side will present an 8-minute opening statement, followed by 5-minute rebuttals. There will be directed Q&A for 25 minutes. I'll kick it off with a question or two of my own. But I think the audience will probably have better questions than me, so I'll try to turn that to you all as quickly as I can. And then each debater will have 3 minutes to make their final remarks. In that final 3-minute speech, neither debater should be making a new argument. Instead, they should just be focused on winning your ballot. And so, as a judge, if you hear a brand new argument in the last speech, if we're going to be super technical about it, that shouldn't be the thing that sways your vote. It's a little unfair because the other debater won't have a chance to respond. So that final speech is really about convincing you. It should not contain new arguments. You should not vote based on new arguments made in the closing statement. With that, has everyone voted? Do we have a way to tell whether everyone has voted? What? You can speak up, it's okay. Okay. The closing statements should not contain novel arguments. They can contain sort of framing and weighing of competing claims and clash, but it's not particularly fair for the final speaker to just drop a new argument that the other debater can't make a response to, and in turn, the first person to give the closing statement should also not make a new substantive argument. But they can sort of weigh competing claims and sort of, try to win your ballot, but it shouldn't just be everything in the final speech should be a derivative of something that was already brought up. Yeah, exactly. That is the final pitch to you, the judges, to sort of win your ballot. It should just not be some new argument from outer space that's the first time you've heard of it. Now, obviously, you're all autonomous agents, you can do whatever you want, but that is sort of the proper way to judge a debate. So, but up to you. I can't control what you click or don't click.
Is anybody able to vote? Yeah. Is anybody
Okay. How about we give it another minute, starting now? Okay. I was just about to say I wish I had some jokes, but yeah, no. I kind of did my knots joke. I thought that was pretty funny. Yeah. To who? Oh, my understanding is that both sides are arguing their earnest belief. Whoa, 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 whoa. Okay, thank you, Rob. I will say, if anybody wants to come to the next Bitcoin Policy Summit, it's going to be in September. It's invite only, but if you email me, I will happily get you a ticket so that the dates are the third week of September, but I don't know the exact dates yet. And so if you want to go talk to Congress about the importance of spam, you know, it's going to be a lot of fun. Again, that's pretty much all I do. Yeah, yeah. No, it's going to be at PubKey DC. Yeah. Okay, has anyone not cast their ballot? Okay, are you planning to vote, good sir? No? No. Okay, fine, whatever. All good. All right, with all of that, I will get out of your hair and turn it over to Rearden to give the affirmative constructive speech. Good luck to both debaters.
Thank you, David, and thank you, Lisa, for organizing this. This is going to be fun, I think, I hope. So I'm here to convince you that quantum FUD is a greater threat than quantum computing. And I think, frankly, I have the easier job up here. Hopefully that turned out to be true, but we'll find out. It is clear that the noise around quantum computing is a real distraction from the critical work of maintaining Bitcoin and moving Bitcoin forward into the future. We have important work to do, like Mars colonization readiness and demurrage, and there's so much important work we need to do in Bitcoin, and the quantum FUD is a pure distraction from that. And this is just like other distractions from Bitcoin, or other attacks on Bitcoin over the years. You know, most notably, I think the big block FUD was very similar. The basic story is, hey, here's a problem. If you don't fix my problem my way, Bitcoin's gonna die, right? That was what the big blockers said. It's what the quantum FUD people are saying right now. It's a new problem, but it's the same structure. If you don't fix it my way, Bitcoin's dead. So I think that's the basic structure of FUD is a problem. And we can see this happening right now. We can see that the FUD is sowing division within the technical Bitcoin community. We see some people that are like super working very hard on post-quantum cryptography, and other people that are basically having to defend against the FUD on the regular. And so there's division there. And then there's also division being sown between the technical Bitcoin community who are either kind of talking against the FUD or kind of defending against the FUD or actively working to solve quantum, and then the financial community, let's say certain people who might be investors in that guy's company, who are basically claiming that that we're not doing anything, right? So like the Bitcoiners are actively doing two things. The Bitcoin technical community are doing one of two things: defending against the FUD or solving the issue. And then there's the FUD out there distracting even from that. And then on the other side, you know, there's two ways for me to attack this, convincing you that FUD is a bigger problem. Either FUD's a big problem, or I can also say, well, quantum's not a big problem, to convince you that FUD is the bigger problem. And in that area, we can see that, you know, at this point, quantum computers are nothing more than a research curiosity. You know, quantum computers really aren't at a point of computing anything at this point in their existence. And so to even be having the conversation about a quantum computer breaking Bitcoin is almost silly at this point. So quantum computers aren't really doing much, and the FUD is actively sowing division in several areas. So I think that's kind of the basics of my argument there. Speaking of those quantum computers, the way I want to kind of structure my argument here that quantum computers are a research curiosity, that we're not at a point where it's time to take action in response to these quantum computers, is to kind of look at the history of digital computing and try to figure out where in that long history we might be. So the history of digital computing started way back in the 1830s with the proposed difference engine from, I think it was Babbage, right? So that's like the very beginning. We had a proposal for a way to do computing using physical devices, and there was a digital computing device. That really, I think he built a prototype and it never really worked, but it was an idea that theoretically worked. Went on, he also proposed an analytical engine, but he could never build it. About 100 years later, there was an actual prototype of the analytical engine built. And so there was a 100-year period there where nothing really progressed in a major way in digital computing. We got somewhere though. And then things started to accelerate, right? About, let's say 20, 30 years later, we got the first vacuum tube computer. Had about 300 gates in it. So that was in the 1930s. The first transistor was introduced in the 1940s. The first transistor computer was in the 1950s. And so let's see, within that time range, where we might be in quantum computing. Has any quantum computer yet been constructed with even 100 physical quantum gates? No. Okay, so we haven't built a real quantum computer yet. We've built things that do quantum computing on individual gates, but we haven't built like a meaningful computing device like we had with the vacuum tube computers in the 1930s. So we're earlier than the 1930s. Has a quantum computer been constructed that can sometimes perform simple computations, like a difference engine or an analytical engine? Yes. So we're somewhere in a wide range between, let's say, the 1900s, 19aughts, and the 1930s. Okay, I know where we are. So what does that tell me about the future of quantum computing? We haven't had our transistor moment yet, right? We have had, within the last year, we've had a bunch of different, we think it's gonna be the transistor, but these might just be another analytical engine or another vacuum tube. We don't know yet because they haven't yet been built into a computer with hundreds of gates that can do meaningful things. So we very clearly know where we are, and where we are is at least decades from the start of the real quantum computing period of human history. And I guess really that's like the crux of my opening. I have 2 minutes left. I kind of prepared for 5-ish minutes. We got 8. So I'll say a few other things here about quantum computing. And one of the things that I want to also just mention here is that quantum computing is in this incredible place where we've invested a ton of money in it because if it works, the rewards for humanity have great potential. We can do new kinds of physics research, new kinds of chemistry research. We can do new kinds of cryptographic research. There's lots of new things we can do. And so tons of money is poured in on the potential. But it's very important for us to separate that potential that is worth investing in when you're going to risk funds on a potential future versus an actual concrete high probability outcome that is worth changing an existing system worth trillions of dollars in response to. So we need to be very careful to separate the amount of money going into it at high risk from the fact that there's a concrete actual outcome. I often hear the argument that quantum computing is definitely going to be solved because look how much money is being put into it. But that is not a metric that tells you how likely something is to be solved, right? Tons of money has gone into lots of things that never got solved. That's just a human nature thing, I would say. I think I might just leave it there. I don't want to keep rambling, so thank you very much for your time.
Wow, okay, cool. Well, first off, I want to say thanks to everyone for having me here, for the hosts of Bitcoin++, and to my opponent here for being willing to do this with me. I hope we'll all benefit from this exchange that we'll have over the next, I guess, 45 more minutes. Okay, so I want to actually start framing this by what I think is at stake, or by what is at stake. So Bitcoin is a $2 trillion asset class, right? And every single Satoshi ever created is secured by the elliptic curve digital signature algorithm, right? And we know mathematically that this algorithm is vulnerable to a sufficiently large quantum computer running Shor's algorithm, right? This is not a speculation, this is a proven mathematical fact, okay? And so the motion before us is really a question around, is the fear and uncertainty and doubt that potentially you could, that arises from this, is that worse than the potential that this quantum computer arises potentially before the Bitcoin network is ready. And I will argue that it is not. I would argue that the FUD is not an existential risk to Bitcoin, but the potential realization of a quantum computer on timelines that maybe are sooner than we expect is an existential risk. And so that's the point that you're going to hear me kind of go into more detail now, and I'm going to make 3 specific arguments. So the first one I want to address is, is this really existential if this is not going to be on a realistic time scale? And I think to some extent, there have been arguments made tonight and previously that quantum is static and is not moving forward, right? But I think one way to rebut that is that progress over the last 5 years in terms of the resource estimates that physicists and computer scientists believe are required for breaking something like Bitcoin have gone down tremendously by a factor of 2,000 times, right? So in 2021, kind of the best known version of a quantum computer, or what was thought to be required for a quantum computer to break Bitcoin required 20 million physical qubits, right? 2024, optimizations brought that down to 4 million. 2025, last year, actually around this time at the Bitcoin conference, Craig Gidney from Google released a paper that required only 1 million physical qubits. Late last year was an architecture that required 100,000, and a couple weeks ago, folks out of Caltech produced a work that basically said, hey, it turns out that if you focus only on ECDSA, you only need 10,000 physical qubits. Now, to be clear, these are resource estimates. These are not actual demonstrations of progress, but they give you a very good sense in how progress is happening inside of the physics world, right? Because I think, as my opponent pointed out, quantum computers can't really do anything very interesting today. And physicists have known this for decades now, right? And so what they've decided is, hey, instead of kind of building a noisy, larger and larger quantum computer that can't do anything, let's address the underlying issues of error correction that ultimately makes this scalable. And that is progress in that dimension is basically what these resource estimates represent. But even though, by the way, I think progress in quantum computing happens in 2 areas. So one is just the physical hardware gets better and you move forward that way. But the other is the bar to clear for Shor's algorithm goes down, right? And so I guess whether I, tell you to walk to a goalpost 100 yards away, and if I move that goalpost 10 yards closer, you walk 10 yards towards it, it's still progress, I would argue, right? But on the hardware side, there has also been progress there. And in fact, the reason that I started Project 11, actually the motivation was Google's result from 2024 around below threshold error correction, which was a really important result. It's a bit of a technical term, but what it means is as you add physical qubits to your system, if you apply error correction a certain way, then the overall noise goes down and not up. So you're exponentially suppressing the error, which clears potentially a path for scaling. So before 2024, that was a theoretical thing. It had never existed. And in 2024, it was demonstrated, albeit at a small scale, but nonetheless demonstrated. That was one of the last kind of true physics breakthroughs that needed to happen in order to make this potentially viable. Right? And kind of on the back of that, last year, a quantum computing company called Inflection actually ran a Shor's circuit for a very small number, 15, but it used logical qubits. It used error-corrected logical qubits for a very, very tiny number, right? And so obviously this isn't, like all of these factoring demonstrations that you shouldn't really, pay too much attention to them. But overall, it does show that the error correction is progressing and the hardware is too. Okay, the next argument I want to make around this in terms of being an existential threat to Bitcoin comes around, is based on Bitcoin itself, right? Bitcoin is hard to change. It tends to be very static, and this is because of the conservative philosophy that surrounds it, right? Unfortunately, there's the potential that it will have to change at some point sooner or later, and unlike many other systems, that process may take longer, right? And in addition, Bitcoin is also potentially much more vulnerable than banks or other parts of the financial system, right? Bitcoin, for example, is a public ledger. It's decentralized, maintained by miners. If a bank theoretically were hacked by a quantum computer, the entity, the managers of the bank could always just erase that entry in the database and basically roll back something that they didn't intend. And so therefore, the ability to profit as a quantum adversary by attacking a bank is potentially less than attacking the Bitcoin network, which is much, much harder to roll back and is entirely dependent on this elliptic curve cryptography. Whereas for a bank, this is just one part of kind of a broader, kind of layer cake of security, right? And I think ultimately, we often talk about when framing this risk is it's the Satoshi coins, right? And there's no telling exactly how a quantum computer will develop and how fast it will be. But theoretically, if you have a fast enough quantum computer, it's not just the Satoshi coins, right? It actually threatens potentially any and all Bitcoin on the network, right? And at the point at which a fast clock, as they're called, quantum computer emerges, that potentially even closes the door for any on-chain migration whatsoever, because as my opponent pointed out on a recent podcast, what Bitcoin did, once there's a fast computer, Bitcoin, as you know, will basically not be usable because the coins will just be stolen by someone else as they try to move. So this, to me, is as existential as a risk as you can possibly get, in my view. And so I think the real, I guess the FUD part of it presents the, potentially, I think the accusation of FUD distracts from the existential nature of this risk and frames this as overly alarmist. And unfortunately, despite the fact that I agree that there shouldn't be any kind of panic surrounding this issue, I think unfortunately sometimes the allegations of FUD create complacency among members of the community and the technical community in particular, that we have time and that we can, we can still fix it and everything is fine and, we shouldn't worry about this yet. We don't want to rush to implement anything new. We should just wait and see what happens and we'll do it later if we have to. Right? But look, Bitcoin is an outlier among the rest of the world in this, right? NIST has said, hey, every government agency, every financial institution, everyone using classical cryptography needs to start deprecating it. Google, in light of their recent paper that came out, basically has claimed that they need to migrate, or they've moved up their own migration timeline to 2029, right? 6 years earlier than they had previously planned. Now, Bitcoin is not like any of these other organizations, thankfully. And there's, more decentralized, and that's a good thing, right? But that also means there are significant trade-offs that we have to face with potentially introducing this new post-quantum cryptography, and that means we should start sooner rather than later and acknowledge this threat instead of calling it FUD. Thank you.
All right, that was great. I'm ready to go. Yeah, those are some great points. I think it's important to remember that we're talking about is the FUD more harmful than the quantum computing? And so I'm going to focus first right there. Bitcoin is hard to change. And partially because Bitcoin is hard to change, any kind of FUD storm makes it harder to know whether we should be changing something or not, or what changes to make. And part of why I've waded into this whole quantum conversation at all is that I want to make sure people are having accurate information about the real state of quantum computing and the real state of the potential remedies against quantum computing so that we make intelligent moves within Bitcoin, because Bitcoin is hard to change. And unfortunately, the quantum FUD, people saying it's existential or that the sky is falling, we have to change fast, we have to move quickly on this. All of that actually distracts from correctly understanding the real potential problems and acting correctly and intelligently to protect Bitcoin's future. So yes, the quantum, if it were to be real, would be existential. And we need to make sure that we have an accurate understanding, not a FUD-based understanding, in order to make correct changes. So the FUD is still the greater threat. Maybe even if quantum is existential, the FUD is still the greater threat to making the correct changes. As a way to kind of make that even like in stark relief, someone could start a FUD storm about almost anything. I mean, David used the example of filters and illicit material on the Bitcoin blockchain. That's a FUD storm. And if we make a change in response to that, it would obviously be an incorrect change. It would be harmful to Bitcoin. So it's very important that we not allow FUD to drive Bitcoin development. Quantum computing may turn out to be a real problem, but any changes we make must be based on evidence that it is a real problem. And as my opponent graciously kind of admitted, right now, quantum computers are laboratory curiosities. They don't do much in the way of real computing. He pointed out the greatest result so far was on the number 15 last year, right? So we're dealing with very small computers that don't really do anything yet. That's the evidence we have. And we need to respond correctly in Bitcoin to the evidence of a real threat and not to ideas of what could be a threat, because ideas of what could be a threat are a dime a dozen. I could come up with a dozen threats right up here on the stage. I'm not going to, I don't have time. Yeah, so just be very mindful that the Bitcoin network is too important to change in response to FUD, and therefore FUD distracts from understanding correctly the evidence and making the correct changes. The other thing I wanted to address from what my opponent brought up here was the timescale and the progress. He's right that there has been rapid progress in how we theorize we can do error correction to reduce the number of physical qubits needed to produce a given number of logical qubits. And that research, I made a comment on X to this effect, has been extremely impressive. Some of the smartest people in the world have done very impressive mathematics on how we can kind of work down the error rate with fewer qubits to get the error rate down, fewer physical qubits to get the error rate down, in order to get to a more useful quantum computer. What hasn't really changed, though, is the number of logical qubits needed in order to achieve a break of SecP256K1. And because that logical qubit target hasn't really changed, kind of the statement I made in the opening of where we are in the history of quantum computing still stands. Because that's what I was looking at when I was looking at these different kinds of computers. It's like, oh, you kind of see something has meaningfully happened when there's 100 gates in the physical computer of some given technology. And we're not there yet in quantum. So we're still in that pre-1930 range for quantum computing, and nothing has changed with that. Nothing has done, none of the research really moved the number of logical qubits down. And then my last point here is about the below threshold error correction, where you can add more physical qubits and reduce the level of errors in your logical qubit in doing so. Again, a very cool result and something important to pay attention to. However, we still seem to see problems when the researchers take one logical qubit and try to add a second in the same device. That tends to increase the number of errors again. And so we're not, quote, below threshold in adding logical qubits. We get more errors when we add more logical qubits. That's about my time. Thanks.
Great. I think I maybe want to start by saying, I just want to address the point around quantum FUD and FUD in general, right? I think in response to my opponent kind of characterizing quantum FUD like other kinds of FUD, I think it's dangerous to equivocate all FUD is equal, right? I mean, I think like 2 megabyte blocks versus 1 megabyte blocks. I mean, do we think this is existential? I don't know, maybe, possibly, versus potentially breaking the cryptographic integrity of the system or of the scheme that basically enables ownership on chain. I think one is different than the other. I think filters, obviously people can have a variety of positions on a number of topics relating to Bitcoin and what they agree with or disagree with, and some may frame that as FUD. But I think in this case, there's just simply no question that if a quantum computer were to exist, it simply would break the underlying cryptography that gives us these inherent guarantees that we come to expect from the Bitcoin network. So I don't necessarily think it's right to call this just like every other type of FUD. The other thing I think is even if we want to just kind of dismiss this as potentially a long time away in terms of it being potentially FUD today because we're just too early, I don't necessarily see a tension between raising awareness or getting started early with potential preparation, right? What's the worst case scenario if Bitcoin introduces some post-quantum cryptography 10 years or 15 years too early, right? I mean, theoretically, we don't have to deprecate ECDSA unless there's an immediate threat, and you can just have effectively some PQ UTXO types there in case you need it, right? So I don't, and potentially having that arguably makes arguing against real FUDsters much easier, right? Because you're like, hey, look, you're telling me quantum's a problem. We already have a solution when the time comes. And I think, so that's maybe the point that I would make on kind of the FUD side. I think on the quantum computing side, I mean, look, I think both him and I will acknowledge that today there is no cryptographically relevant quantum computer, and quantum computers are embarrassingly just bad at everything. It's not a question of whether that's where we're at today. It's a question of how quickly will that change. And I don't necessarily think that we can draw a direct comparison to the path of regular analog computing back to the 1830s and assume that quantum computing is going to be a decades-long time path. I mean, even 100 years ago when vacuum tubes were first invented, I mean, the world is very different now. For one thing, we have access to a lot of advanced, the internet, advanced AI, a lot of different technologies. I just think the world is a different place. And I actually think if you look at the progress that AI has made in a relatively short time frame, you can see exactly how the exponential progress of a given technology can quickly outpace people's even wildest expectations, right? And in the case of quantum, this becomes kind of tricky because we're talking about a technology here that, yes, I agree will be great for humanity in many ways in research and in molecular biology and material science. But it also, as the point that we're talking about this at Bitcoin++ is because there's also a use case which is cryptanalysis. Who cares about having this capability of cryptanalysis? Well, two categories of people. People that want to make money on the Bitcoin network, basically by stealing Bitcoin, and governments, they want to read other people's mail, more or less, right? So folks that are building these systems, or more like funding these systems, have every incentive to ensure that their capabilities and their progress remain secret. By the way, this is not like a theoretical, I'm not paranoid. Like Google, when they published their latest resource estimate, actually, and by the way, this included an actual circuit for Shor's algorithm, but it didn't include the circuit itself. It included a zero knowledge proof that they had compiled such a circuit, right? And the explicit reason that they did that, they cited in the paper, was because they did not want that information to potentially get into the hands of someone who might misuse it, right? And so I think on the trajectory of, hey, how do we know when we've gone from this is a decades away problem to a years away problem? I think that's a very fair question. And I would love there to be a clear signal. I'm just not sure that in light of effectively the capability that this weapon provides you, that you will necessarily see that progress in the open. And this adds to the uncertainty around this problem. And in light of this additional uncertainty, I think adds urgency to just have a contingency prepared. Thank you.
All right, and now we are at the Q&A period. So one question I had for you, Alex, is I feel like there was some pretty good clash around the sort of progress argument, where Rearden sort of made the argument that progress really isn't happening at all, and that if we were to map this to classical computing, we're somewhere pre-1930s. Alex, you made sort of the argument that in fact there's been a 2000x decrease in the logical qubits needed, that hardware is improving. Rearden responded by saying maybe there is some progress in theory, but each of these additional qubits is actually increasing the overall error rate. So I feel like there was good clash of ideas there. My question for you is, how many iterations of quantum computers do you think we'll need before we get kind of a sense of what the slope of progress looks like? Or is your argument that it will just be 0 to 1?
My argument is that I don't know if that's a knowable. I don't know if that's knowable. I think physicists that are working on these systems, if they knew how to build a quantum computer, they would have definitely done it already. I think many of them would have saved themselves the embarrassment of having failed previously. And look, I think the reality is no one really knows how many iterations away we are. And to be charitable to my opponent, I think he actually did acknowledge the progress that has been made. But I think his argument is that there's still a long, long climb ahead. And I actually don't disagree that the task in front of quantum physicists and quantum computing experts is hard. I think the question is how quickly can they run up that hill? And I think as Scott Aronson, who's a noted quantum physicist at UT Austin, has put it, sometimes people can amaze you with the miraculous things that they're able to pull out of a hat. And he uses specifically the example of the Manhattan Project, right? And so it's not clear. I don't think we know exactly how the trajectory of quantum computing progress will happen. I certainly don't. And I would posit that no one does. And as a result, we have to account for the possibility that it's faster than than we would maybe want.
Okay. Rearden, a question for you. You opened the debate by making the argument that FUD is a distraction from other work on the protocol, that the attention of developers and the community is inherently zero-sum, and so if we're sort of focusing on quantum, we're not focusing on other things. Notably, you didn't make the argument that I've heard a lot of people in this debate make, which is that some solutions to quantum maybe net bad, that the medicine is sort of worse than the disease, so to speak. I'm curious, is there a reason you didn't make that sort of line of argument? Is that not a view that you hold? Is that just not an argument that you wanted to make today? Because I understood your argument to be that there isn't actually a risk of changing early. It's just that it's a massive distraction and, minus EV for Bitcoin because there's other things to do that are more important. So I'm just kind of curious what your perspective there is.
Yeah, I do think that there's a risk of doing the wrong thing too early. I was just, it didn't seem like the strongest argument for this specific proposition. So I was going to bring it up in closing, actually, so thank you for the opportunity. Yeah, I think that there is significant risk of bringing in the wrong cryptographic solution to quantum. And we raise the risk of that because of the FUD, making a wrong decision and doing the wrong crypto. I was arguing about that with Shinobi earlier today.
But just to sort of play devil's advocate, in theory, if the risk of a change, if there's a risk that a change winds up being net bad, wouldn't you want a longer time period by which the community can debate that change rather than potentially compressing it?
That's my point, that the FUD forces us to compress that timeline, and I want to have patience and time to get the right change in.
Okay, cool. I honestly think that's it for my questions. I'd rather go ahead and turn this over to the audience. Okay, Shinobi.
Here it comes.
I just wanted to, your example, you essentially argued that trying to map things to mechanical and then conventional digital computing was a bad way to go about things, and you used AI as an example. But in fact, the mathematical underlyings of AI, go back all the way to the 1960s. The underlying mathematical models and the entire structure for that was 50, 60 years before any meaningful progress beyond little toy examples came. So I kind of just want to put you on the spot here. Do you have any other examples you can think of a brand new technology that didn't follow that same curve of a long flat tail for a very long time before the exponential progress took off?
I should sit here and look uncomfortable for a few seconds while I contemplate. No, I'm just joking. Great question. Thank you. So first, let me give you two examples in a second, but I want to thank you for your question. Quantum computing has been theorized since the 70s. I think David Deutsch came up with this concept. So this is kind of around the same time as AI, and certain, I'm not saying it's necessarily going to follow the exact same timeline, but I'm maybe just arguing against using any analogy around what has taken what amount of time as good. I think it's kind of arbitrary. And this is my point. I think this, we don't know exactly how the curve will change and how people will traverse it. But I think there is definitely examples of advanced technology that's gone much faster. I mean, I think if you look at nuclear physics, right, in the 40s, when people came up with the idea of, hey, you might be able to create energy by splitting the atom, going from that to the idea to actually splitting the atom. So even understanding that atoms were a thing to splitting the atom was about a 50-year time frame, right? So I mean, that I think happened a lot faster. I mean, you look at things like jet engines, right? I mean, jet engines were people came up with them in World War II as a wartime innovation, and very rapidly they became adopted everywhere. Are these good analogies for quantum computing? Probably not exactly, but this is my point. I think there's a lot of examples all over the map, and I just don't think that picking the example of the digital compute, the path that classical computing followed, I just don't necessarily think is exactly analogous to what quantum computing will follow.
Anybody have a question for Rearden? We want to try to keep these relatively balanced. Rob?
Mike?
Thank you, yeah. So for Rearden, The uncomfortable position I sit in as someone who I would say generally falls on your side of like point of view in the debate is I never want to be in a position where I'm short the innovation of mankind, right? And having seen Alex's talk at OpNext, there's not just a quantum computer solution problem, right? There's many different approaches with different trade-offs and all of these things. And while I agree with your general premise of at the moment the FUD, and I think what's more interesting probably is the Satoshi coins and how things get activated, like the consensus piece than the actual fixing it. Like, how do you feel in the sense of with rapid expansion of technology in general, there's many people that are taking many different cracks at doing this and being in a position of saying that like it's not going to work and just being short all of this capital, all of these labs and research, and that many people from many different angles are trying to get it, and only one of them has to get it right for the position, you know, that it's actually valid and cryptography is broken in Bitcoin.
I mean, I would just say that for the purpose of this debate, it doesn't matter. So what matters is that the FUD makes it harder for us to create the correct solutions regardless. And so I've said this on podcasts, but I think it's worth repeating. I don't think that a quantum computer is possible. I think we're going to find physics doesn't allow it to break like Bitcoin. However, I'm very confident that the timelines are not what the Google folks are saying. Like, it's not a 4-year issue, it's a 10+ year issue. And of that, I would bet my life savings on it. I have my life savings in Taproot, so I essentially have bet my life savings on it. And so given that, we should take the time to do this right, and so we should not let the FUD push us to early wrong solutions, and the FUD is therefore the greater net harm. We want to take the right time, because maybe I'm wrong, and if I'm wrong, I want to have a good solution that I can move my coins to before I'm proven wrong.
Okay. Anyone have a question for Mr. Pruden? Not Shinobi.
There's a couple over there.
Yeah, in the back.
I promise I won't run away after this, Shinobi, so you can find me.
So I thought jet engines was an interesting example because the way I would go describe that is it shows how often technology is very limited by physics, where you have something that we don't have it at all, it very rapidly advances, and then quickly we reach the limit of physics and it just stops advancing for the most part. In another very interesting example of this is analog computing, which the math of analog computing does break crypto. And no one thinks that breaks crypto because no one believes analog computing can get to the degree of precision necessary. Or even conventional computing. I mean, conventional computing, yeah, it breaks crypto. It's just we've set crypto parameters such that you need things like, you know, convert the mass of the sun into energy and so on. So my question to you is, would you accept that there can definitely be a world where the answer is, yeah, all right, quantum computing is real, but the cost to make a quantum computer scales exponentially with its conventional equivalent, and thus it's worthless?
Yes, I accept that's possible. I don't know that to be true, though. And let me, actually, first off, I think I'm really happy you brought up this concept of analog computing, because I actually heard quantum computing described by a quantum computing expert this way, as like quantum computing is like analog computing, but with error correction, right? Because the issue with analog computing is that, and by the way, what is analog computing for everyone who doesn't know? It's like, you know, digital computing is 0, 1. Binary, it's very easy to tell what value your bit is in, or your unit of compute. And analog computing gives you any value, right? Kind of like quantum does, basically. And the issue is that you can't tell values apart, you know, in the computation. And the whole point of quantum error correction is to be able to enable you to cut through the noise and do just that, right? And will it work at scale? That's not known. But could it possibly, do we know that it won't work? You mentioned physical limitations. You know, physics obviously like to prove or disprove things by experiment, right? Every experiment, which is basically any quantum computer at any scale that's ever been run, the error correction has worked. So I think if you believe that error correction won't work at scale, I mean, we have to expect that at some point there will be an experiment, you know, some quantum computer of a certain size gets run, and then there'll be some revelation that physics doesn't allow it. But to be clear, I don't think we can conclude that based on today. And I think on the jet engine point, look, things do plateau, but there are also things plateau for a while, but then there are breakthroughs. I mean, look at ramjets, look at scramjets. I mean, these are arguably innovations around, you know, the similar ideas that inspired jet engines. And so I don't think it's necessarily right to say that, you know, it all plateaus at once, and there's no more innovation ever again. So thank you for your question.
Anyone have a question for Brandon?
It seems like your argument about FUD is at risk of tautology in the sense that it's sort of like good consideration of quantum solutions is good and bad considerations of it is bad. And I'm wondering if you can provide some kind of like line or criterion, like we want some motivation to pursue this problem. What is the right kind of motivation or level of motivation?
Yeah, it's a great point, and I was thinking about it in the way I was expressing certain things as well, so I appreciate it. I think this is, again, the reason I waded into this whole quantum thing was I wanted to make sure that I had an accurate understanding of the state of the science and where we really sit and what is possible right now, what has changed over the years, kind of, is there a trajectory of change that we can look at? And so I think that's what I think, essentially, FUD is what comes out of press releases and marketing, and rational understanding and kind of correct scaling of concern is what you get from reading academic papers. With one notable exception, which actually was this Google paper that Alex mentioned, where they redacted the actual circuit. I would say that action itself was a FUD action in redacting the circuit. They were like, "Oh, you should be so worried about our discovery is so good. You should be so worried we had to redact it." They're basically FUD-based science. So most of the scientific papers are actually excellent and not FUD, but then most of the PR and marketing is. So that's really kind of where I weighed in is. We should really read the literature, and I encourage everyone to read the quantum papers. It's actually kind of fun to learn about these things and see the really exceptional math that's happening, but don't listen to the marketing. Thanks.
Can I ask a quick follow-up? How do you know that the use of ZK proofs in that paper was marketing?
Because they didn't change anything fundamentally. Again, as Alex said, they drastically reduced the number of physical qubits needed to potentially implement the circuit. They didn't change the fundamentals of Shor's algorithm. They didn't change the number of logical qubits required. They didn't change the number of cycles required, which is the time it takes to execute the thing, and that's one of the great constraints on quantum. And so to not publish it was just like, oh, and I said it in a tweet, a smaller impossible thing could maybe do the thing if the impossible thing was ever possible. That's the result that they didn't publish. It was just ridiculous.
Well, I think, if I may make a quick point, I don't think it's correct to say they didn't reduce the number of cycles. I think they did, right? So there's a space-time trade-off around Shor's algorithm, and I think there's a chart in there that showed that, hey, for the same number of logical qubits, this circuit that they had, which applied to near correction, only required, I think it was 70 million Toffoli gates, which is kind of this critical path, operation, as opposed to the prior state-of-the-art required, I think it was 100 billion gates. So I think there was a meaningful reduction in terms of cycles. But still not a demonstration of physical capability, certainly.
Okay, Brandon, I think you mentioned you had a question for both debaters.
Yes. Well, now maybe I just have a question for Alex, but we'll see. And trying to pose this in a way that's not meant to come off as like offensive in any way, but
Don't hold back.
There's the old saying of like, show me the incentive, I'll show you the action, right? And obviously you run a company focused on solving quantum issues around Bitcoin. How do you sort of separate the implicit incentive in sort of raising the alarm for this with sort of the duty of your perceived kind of urgency around the issue?
Yeah, I think that's a great question, and I don't take offense to it. Look, I work on what I believe in. And yes, I have raised money around Project 11, which is a company that's focused on applying post-quantum cryptography to blockchains and digital assets generally. If I can just be open with you guys, the amount of dollars I've made from Bitcoin or any digital asset network is, I think, -1 Bitcoin. We gave 1 Bitcoin away for the Q-Day prize today. So I'm currently at -1 Bitcoin in profits. But yeah, no, look, I just, I passionately believe in the importance of digital assets and protocols like Bitcoin for humanity. And I also believe that solving this problem, should it emerge, will be extremely difficult. And quite frankly, Project 11, my focus is less on, I mean, I'm happy and maybe even humbled sometimes to be a part of the broader dialogue with so many incredible people, including Rearden, who've contributed to this protocol over time. Candidly, Project 11 is more focused on, I would say, the institutions that ultimately sit on top of all these protocols and, you know, give people access to them in various ways. And so that's sort of my focus. But ultimately, I don't feel bad about necessarily having a commercial interest in applying post-quantum cryptography, because I think there's a consistency between post-quantum cryptography is good because we need it to ultimately be future-proof, and I also think there's a commercial opportunity. I think, you know, ultimately, this is the idea that makes capitalism powerful, I think, potentially. People follow their incentives, and ultimately, over time, you know, these incentives create net better systems. And so I sort of, that's how I view what I'm doing. So I think that's a fair question, though.
A quick follow-up to it is, you know, the idea of the debate is, you know, is the FUD more harmful than, you know, the issue? Would you consider kind of in your framing of your argument, like, is Project 11 contributing to the FUD from your standpoint?
You know, I hope not. And also, I think going back to how I characterize FUD, I don't think all FUD is created equal. Look, I mean, I think this is an existential issue for a network that I feel very deeply about is its importance. And so, to the extent that I am being loud and it's saying that this is a problem, I'm doing that because I think it's just important. And I think that Bitcoin should address this, like many other institutions and other digital asset networks are, right? I just think this is an important issue. Whether or not people frame that as FUD, I guess is up to them, but I mean, it doesn't change what I fundamentally believe about this, regardless of any commercial interest.
Does anyone have a question for Rearden? No, but you do. Kyle, I'll get to you next.
So one of the things that I worry about a little bit in Bitcoin is our inability to make any changes, even if they are like important for the security of the protocol and for the usefulness of the protocol. And so my question is if the side effect of the quote-unquote FUD is that we have activity and we have a group of people that are outside of the typical maintainers that have been the ones to promote changes, the only changes we've seen at the protocol at consensus layer over the past 10 years. If we see some new change come in, even if that is maybe upgrading to a new version of Taproot that doesn't have naked public keys and you know, we get Taproot minus the quantum vulnerability, wouldn't that be a good thing then and like a benefit then of the FUD if it moves us in that direction?
Yes and no. So I admit I have mixed feelings about what you're saying. You know, like I'm afraid to debate a particular proposition, and I'm doing that. That said, I've found myself regularly having to kind of defend the position of, you were kind of talking about BIP360 here. BIP360 is good, but not because of quantum. And it's a kind of a silly position to find myself in. So on the one hand, did quantum FUD help move BIP360 forward? Well, maybe. However, BIP360 was also, that exact same idea was proposed as part of the script restoration, and I would rather it had come from that direction. So I think in this case, the FUD was kind of neutral. We're getting the same thing that was proposed in the other direction anyway. It just has a different support behind it. And so we just have to be careful that we're not kind of attributing that idea to a post-quantum idea only. It was also proposed elsewhere.
Okay, and in the interest of time, I know Shinobi's going to beat me up if he doesn't get his second question. So Kyle, could you ask your question? Shinobi, you ask your question, and Mr. Pruden, you answer them in turn.
All right, yeah, just pass around. Give everyone rapid fire shot here.
Cool.
Yeah, this was a question that I had framed, I guess, for both of you. I don't remember exactly where I read this, but I heard something of the order like 60 to 70% of the activity in the developer ecosystem in Bitcoin right now is dedicated toward quantum in some nature, like it's like the overwhelming majority or plurality of people's time. So if you were going to like suspend your mutual belief or disbelief about whether or not we are going to be able to, whether this is an issue that we have decades or whether it's something that we only have like 5 years to think about. What would we say is the appropriate amount of brain space and scarce limited development time to be spending on this issue relative to the enormous number of other very serious problems that we need to solve in the Bitcoin community?
Sure.
Let's get Shinobi's question.
Okay, so quick answer. I think somewhere on the order of 20% of our time should be working on new crypto systems for Bitcoin. Maybe even a little more, but it's not specifically post-quantum crypto. It's just generally new crypto systems. SecP 256K1 will not last forever, regardless of quantum.
I think the attention, I view, my kind of read on the developer discourse in Bitcoin today is that this is, as you framed it, maybe 60 to 70%. And a lot of people are paying attention and working on it. And I applaud that. And I applaud everyone who's doing it. And I applaud all the solutions that have been proposed. And I have nothing negative to say about folks working on it. And I think, maybe the way it was characterized before is that, there's some like highlighting the risk of this issue kind of risks that we do bad things as a result, and I think that's mitigated by the fact that a lot of people are working on it. And I do think that for me, there's a lot. I think to Rearden's point, look, there's a lot of unknown unknowns. To the gentleman over there about who asked the question about like analog computing, like we don't know classical cryptography is not broken. Like we just don't. We don't know P is equal to NP. Tomorrow something could break, and we should be ready to migrate because ultimately this Bitcoin is just too important to fail. But we do know that quantum will break Bitcoin if it is to happen, and I think also because it has kind of entered into the discourse among specifically prominent members of the Bitcoin community, especially among the capital holders and potential adopters. I think it's just right to prioritize as a technical issue because I think you'd be hard pressed, again, and this is the point that I'm arguing, you'd be hard pressed to find a more existential threat technically to the Bitcoin network, in my view.
Okay, we've got about 20 seconds left. Kyle, I'm curious.
I purposely talked longer so Shinobi wouldn't ask me the question.
Well, good debating tactic. I'm also curious where you got that stat about 60%. That feels intuitively wrong. I'm curious where that came from.
Again, I don't remember the source, but it was like either the mailing list or like dev project funding or something to that effect. It's a lot like.
Wasn't there a thing like Adam Back said like 70% of Blockstream is working on it or something?
Maybe it was
something like that.
Okay, well, let's get to closing statements. Thank you both. All right. So we've talked about a lot of things. One thing I really want to focus in on a little bit more is what's the worst thing that can happen from pushing a replacement crypto system into Bitcoin? And Alex just mentioned this a little bit, like the risk is that we will mitigate the risk that we do the wrong thing because we have good people working on it. And the FUD can reduce our ability to do that. We can even see that Taproot, in a certain sense, Taproot was FUDed into early activation and probably wasn't quite ready. And so we've had a situation where we activated something that had a recent change in the 32-byte pub keys that is a challenge for Bitcoin going forward. And this could be a much worse situation. So we should be very mindful that by pushing kind of public FUD, we could create a bad outcome, a really bad outcome. And I also want to be clear, by the way, that Alex is not a FUDster. Like, we're debating this does not mean that I think he is a FUDster. There are FUDsters out there, and like I said, the Google paper is an example of FUD, but Alex is not, and that's why we can have a respectful conversation like this, because over a brief, somewhat heated debate, we got to the point where we could talk like adults. And so, yeah, I want to make that clear. Another thing I wanted to mention here, there's this common thing, and Alex just did it right now, and I don't, again, no slight here, it's just a thing that happens often in the quantum debate where people say, a quantum computer will break Bitcoin, if. And it's like, so you've used this word will, and it implies a certainty that doesn't exist. And then sometime later you say, if it gets built.
And we need to be very careful when we hear that will-if structure, because you're kind of loading the person's brain with the inevitability and then accepting the conditionality of it. And that's, again, where I think the FUD comes from, is people hear that, and that triggers their brains in this it's an urgent, we have to do it type of situation. So yeah, just to kind of wrap up here, my argument is that we should be making changes. SecP T6K1 will break. We should be researching new crypto systems. We just shouldn't be doing it in a kind of FUD-driven development sort of way, because if you think about the risks to Bitcoin, FUD-driven development is a much greater risk than quantum computing or classical computing breaking SecP. And that's really all I got. Thank you very much.
Yeah, first off, I just want to thank Rearden again for doing this debate with me. I had a lot of fun, as he pointed out. We've had some discourse in the past, and it's great, and we've been able to discuss this issue, and hopefully it's an example of the ways that folks can disagree and still discuss civilly other issues that ultimately affect Bitcoin. Because I mean, ultimately we own the system, all of us, right? There's no centralized party that manages it, right? We come to decision by consensus. So thank you, and I really want to say again that I respect all the work that he is doing and has done for the Bitcoin protocol. Look, I'm not a quantum physicist, in case that's not obvious, right? I actually 15 years ago, I was walking around the mountains of Afghanistan as an infantry guy, right? That's like a ground pounder, kind of the guys who are like not smart enough to fly helicopters, okay? So look, I kind of come at this from a mindset of, actually that I kind of used in those days, where when you plan a mission, you think about what is the enemy going to do most probably, and what could be the most dangerous thing that they do, right? And whenever you plan to go out of the wire, you always try and account for the most dangerous course of action, right? It's not sufficient to just do what you think they're most likely to do, right? And I think in this case, like, it's not just, it's the question is not, will a quantum computer exist in the next 5 years or 10 years or 20 years? It's, are we certain that it won't exist? And I think if we're not certain, then I think we need to prepare, right? And so, and against this risk, which is potentially existential. And so here's what I'm asking you guys to take away tonight. So I think there is evidence that quantum progress is happening that is not marketing. And I've given you some examples of that, some reduction in resource estimates. There is even the progress in below threshold demonstration, and even the running of a logical short circuit. Two, I think Bitcoin is just more vulnerable, frankly, than many other systems out there, and I think than many people would unfortunately like to admit. I mean, the fact that it is decentralized is its greatest strength, but also I think potentially this single layer, this cryptographic authorization that is uniquely vulnerable to a quantum computer is a big weakness here, right? And I think we just need to acknowledge that there's a potential that this is one of the first targets, not one of the last targets. And three, I think the FUD framing is not protecting Bitcoin. I think it's potentially disarming or making light of something that I think people should be paying attention to. And I think if we proactively address this concern as a community, then we take away ammunition from the real FUDsters, the people who don't believe in Bitcoin in the first place, the people that are using this as an excuse for why it's doomed to fail. Like, let's just take that out of their quiver, right? And let's address this proactively. Let's make Bitcoin the future-proof, ironclad guarantee of individual monetary sovereignty that Satoshi envisioned it to be. Thank you.
All right. Well, I thought that was very well done by both of you. So thank you for keeping it civil and constructive. What is the process by which people recast their votes? And Shinobi, next time you want to ask questions, you should put whichever one you want most first, because typically you get one question, You
were talking to a literal retard.
Just a shout out to both of our debaters for spending a ton of time preparing and actually going hard at this. It's really entertaining when people try hard to win. I'll also thank you to our phenomenal moderator, David Zell, for stepping in and doing this. So as you guys get your vote in, just, yeah. Also, just another shill. So Bitcoin++, this is the third kind of version of this that we've done. This is the third conference we've done debates in. We're interested in feedback. We want to do more of these. We think that they're getting at something like interesting in Bitcoin, something unique. If you have ideas for motions or things that you think would be, a good fit for this stage, please let us know. So with that, I think it's time to close the voting and announce, or is anybody still voting? Cool. If you could open up, yeah, click finish. Hopefully that works. If you could open up the roughconsensus.xyz and go to the website. Let me come up there. Let's move on.
All right.
So curious.
I was gonna say, the result might be as interesting as like the delta, like who actually flipped, one person maybe.
Yeah, you can go to the website, click the debate thing, so we can put it there. I'm trying to log in.
Okay. This was a very close debate. I will say there were 30 votes cast in the pre-debate and 28 votes cast in the post-debate. So 2 people did not vote. Pre-debate, 17 of the votes were for the affirmative, that FUD is a greater threat than quantum computing. 6 people out the gate agreed with Mr. Pruden, and 7 of you were undecided. After the debate, Mr. Rearden lost 1 supporter. Mr. Pruden gained 2 supporters, and 3 of the undecideds went away. So by a 9%, i.e. 1 person vote, the winner is Alex Pruden.
To my one true fan out there, thank you very much. I appreciate that. Shinobi, I know it wasn't you.
Can we get another round of applause for not just our amazing debaters, but everyone who showed up and presented the last 2 days?